Today I want to look briefly on something related to rationalization method. We had already done three methods. The first one was by direct substitution. The second one was factorization. The third one was L'Hopital's rule. Now we are looking at the third method, that is called rationalization method. Now, rationalization method is a method that is used for functions that are containing SAD so that you can get their limits. We call it rooted function or function containing SADs. You can use the rationalization method to evaluate their limit. That is the only specific way for rationalization method. For rooted function, you cannot use any other method. You cannot use LH, which is L'Hopital's. You cannot use factorization, though it goes hand in hand with rationalization later. But basically, rationalization is the method that is being used. Now, I have an example there. Limit as x tends to 0 of 1 plus x minus 1 minus x under root divided by x. Now, before I evaluate this, I need to bring you to knowledge about something related to conjugate. Now, a conjugate, in case you have 1 minus root of x and you have been told, write the conjugate of that function. How do you write that? Easy. Just change the sign in between 1 and root of x to plus. As easy as such. Now, what about in case now you have root of 1 plus x minus root of 1 minus x? How do you get the conjugate? Very easy. Just change the sign in between there to plus. If it was plus, change to minus. If it is minus, change to plus. As easy as such. Now you have understood what is a conjugate. Now let's evaluate our example. So now the first method is direct substitution. If you haven't watched the previous videos on direct substitution and the L'Hopital's and factorization method, please do so. But the first method is direct substitution. You can't use any other method. The first one that you have to start with is direct substitution, regardless of the question. So by direct substitution, we are going to be having root of 1 plus 0 minus root of 1 minus 0 over 0. So we are going to be having root of 1 minus root of 1, which is 0. So it means by direct substitution, we get 0 over 0. 0 over 0 is not a limit. So we have to use another method. Now, this is where now rationalization comes in. Now, by rationalization, we are going to be multiplying the conjugate, the numerator, the function there, by the conjugate. Now, this is our function. The conjugate we are going to be getting from the numerator. So now, because it is only in the numerator that we are having a root. So the conjugate from the numerator is root of 1 plus x. Change that minus to plus now. Change that minus to plus now. Sorry for the system there. It's a slight malfunction. Change that minus to plus. So it is going to be root of 1 plus x plus root of 1 minus x. That is the conjugate. So use that to multiply both the numerator and denominator. When you do that, you are going to be ending up to the highlighted point. Numerator is root of 1 plus x minus root of 1 minus x. The other part is the conjugate. Now I've used it to multiply both numerator and denominator. Then now, before I proceed, I need to bring you to a knowledge, a basic concept, of course, of product of two squares. And it says, when you take a plus b multiplied by a minus b, you get a squared minus b squared. So if you let our a be root of 1 plus x and let our b be root of 1 minus x, then it means a squared is root of 1 plus x squared and b squared is root of 1 minus x squared. So it means we are going to be ending with a squared minus b squared, which is here. Root of 1 plus x squared minus b root of 1 minus x squared, the denominator we maintain together with its bracket, the bracket for that conjugate, we maintain that. Then now, when you square a root, you end up with what is in the bracket. So it means we are going to be having 1 plus x, which is inside the root. What was in the first root was 1 plus x. So the square and the root cancels, you remain with that. Minus 1 minus x. And the denominator maintain. Simplify this further, we are having 1 minus 1, 0. X minus x, which is x plus x, 2x. So that's bring us to this part. We are having 2x divided by x into the conjugate. Now the last part, now this part that we are getting there, we are getting by cancelling the x in the numerator and the x in the denominator, so that we are having 2 divided by root of 1 plus x plus root of 1 minus x. The next thing, direct substitution. By direct substitution, substitute wherever you have x with 0, because our limit was tending to 0. So you are going to be ending up there. So 2 divided by root of 1 plus 0 plus root of 1 minus 0 from the other part. So that now you are going to be having 2 divided by 2, which is 1, and that is the answer. The answer to that question is 1. The limit of the function that we had there is 1. Thank you for your time. Please subscribe. We are going to be having more and more videos and more recordings about this rationalization, because it is a complex method. I'm going to consider it. I'm going to do 2 more example, complex ones, of course. That is going to be jump-starting your brain. Please subscribe. Don't let yourself be left out. Take your time, subscribe, watch, comment. If you have a question, just write there. We'll be able to consider it. Take your time. Share the video, share the link to this group, this YouTube channel, and then we'll be helping other people the way you have helped yourself. Thank you for your time.